So, good evening, everyone. Actually, we have been discussing the concept called electronic effects. Basically, we have discussed inductive effect. I think all the three students are new to my class, right?
Yes, ma'am.
Okay, the first class in any okay, right. Anyways, you guys are entering into 12th. So, I believe the concepts which I've taught already would be very comfortable for you. If you have any doubt, please come up with your doubts. I'll clear you. Okay. So actually the topics are yes, Vishwabala. சொல்லுங்க கண்ணா.
Ma'am, I am new to school. I am new to class, ma'am.
ஒன்றும்
இன்னைக்கு தான்
பிரச்சனை இல்லை
மேம் ஃபர்ஸ்ட் வந்திருக்கிறேன் மேம்.
ஒன்றும் பிரச்சனை இல்லை
ஓகே மேம்.
பிரச்சனை இல்லை 11th
ஓகே
டாபிக்
மேம்.
தான் கண்ணா இது. ஸோ அதனால உங்களுக்கு கம்ஃபர்டபுளாக தான் இருக்கும்.
ஓகே மேம்.
டவுட் இருந்தால் கேளுங்க. சரிங்களா?
ஓகே மேடம். தேங்க்யூ மேம்.
So initially we'll start with few questions which are basically from electronic effects, which is the topic from general organic chemistry. So I'll show you a question and I want you to understand the question and try to answer it. And if you have any doubt or if you have any problem with your concepts, please let me know. We'll sort it out. Is the screen visible, Kanna?
Yes, ma'am.
Okay. So the question is, which of the following carbocations will be most stable? We have 4 options. In each option, we have different types of cations and we have to find which carbocation is most stable. Carbocation, carbon with positive charge, which is basically an electron deficient carbon. Okay, Rohan's answer is option A. We'll check Rohan. Carbocation, carbon near iony. So, Vishwa, you have any problem in understanding the question?
No, ma'am. No, ma'am.
Okay, fine. So, the first option is this is positively charged carbon, and this positively charged carbon is attached with 3 pH groups. What is pH group? That is our phenyl group. So this is option number 1. Okay. So option number 2 is CH3, which is attached with CH2. And third option is positively charged carbon is attached with 1 hydrogen and 2 methyl groups. And fourth option is CH2, double bond CH2, double bond CH, single bond CH2 plus. Okay, Janani?
Yes, ma'am.
Answer, Janani.
I'm not sure, ma'am, but maybe option A.
Okay, fine. Vishwa? Vishwa, option எதுவும் இருக்கா கண்ணா? Okay, பாத்திரலாமா? We'll check. Guys, listen. First, we'll understand the problem of carbocation. So, see, basically, guys, listen. Basically, a carbon atom should have 4 chemical bonds. A carbon atom with 4 chemical bond is most stable. So carbon atom should have its proper number of electrons. Then only carbon atom will be stabilized. If suppose carbon doesn't have any electron, or doesn't have any sufficient electron, or got extra number of electrons also, that makes the carbon unstable. Okay, so carbon should contain proper number of electrons. Carbon shouldn't be electron rich or shouldn't be electron deficient also. Fine, you're getting my point. So carbon should have proper number of electrons. As far as carbocation is concerned, this carbocation is an electron deficient carbon. So carbon doesn't have its electron. So carbon lost its own electron. So this is unstable. So we have to check, though all the four options are electron deficient carbon, among those four, we have to check which is the most stable carbocation. So you would have studied the stability order of carbocation. Generally, tertiary carbocation is more stable, then secondary is more stable, then primary, least is methyl carbocation. More than tertiary carbocation, allyl carbocation is stable. More than allyl carbocation, benzyl carbocation is most stable. Do you know how to represent this benzyl carbocation? How to represent benzyl carbocation? Okay, listen. See, a positively charged carbon, if it is attached with a benzene ring, then this is called benzyl carbocation, which is the most stable carbocation. If all the three hydrogens were replaced with benzene, then that is even more stable. Okay, so this is benzyl carbocation, which is the most stable one. Next is allyl carbocation, which is CH2, double bond CH, single bond CH2 plus. So what is allyl carbocation? Positively charged carbon is attached with sp2 hybridized carbon, right? So this is allyl carbocation. What is tertiary carbocation? Generally, positively charged carbon is attached with, if it is attached with 3 alkyl groups, then this is tertiary carbocation. If positively charged carbon is attached with only 2 R groups and one bond is attached with hydrogen, then that is secondary carbocation. If positively charged carbon is attached with only one R group and rest of the bonds were filled with hydrogen atoms, then this is primary carbocation. If positively charged carbon is attached with only 3 hydrogen atoms, then this is methyl carbocation. This is the stability order, Kanna. And as far as benzyl is concerned, this benzyl group contains only one benzene ring, so this is primary benzyl. If this hydrogen is also replaced with one more benzene ring, then that is secondary benzyl. If this hydrogen is also replaced with another benzene, then that is tertiary benzyl. If number of benzene ring increases, then stability also increases. So this is the stability order. So from the stability order, we're going to answer this question. So this is your benzyl carbocation. Not only this is benzyl, but also this is tertiary because we have 3 benzene rings, right? As far as second option is concerned, what kind of carbocation is this? This positively charged carbon is attached with only one R group. So this is just primary carbocation. How about third option, Kanna? How about third option?
Sorry, ma'am. Or chinna network issue, ma'am.
Paravala Kanna, paravala.
Okay.
So how about third option? Positively charged carbon is attached with 2 R groups. So this is secondary carbocation. And this positively charged carbon is attached with sp2 hybridized carbon. So this is allyl carbocation. So the stability order is this one. Benzyl is most stable, and allyl next is tertiary, next is secondary, least is primary and methyl, right? So according to this stability order, could you please tell me which is most stable? Answer is option A. Okay. Janani, are you clear, Kana?
Yes, ma'am.
So, as far as carbocation is concerned, this is the stability order. Okay. If suppose, one more question, listen. What kind of carbocation is this? Is it primary, secondary, or tertiary? And what kind of carbocation is this? Is it primary, secondary, or tertiary? Yes, Janani? Yes, Rohan, you're right. It is. Sorry, Kana, I couldn't hear you.
Primary, ma'am.
Okay. See, this is positively charged carbon, and this positively charged carbon is attached with 3 R groups. So if it is attached with 3 R groups, then this is tertiary. Okay. Abhinaya? Kana, is this your first class, Abhinaya?
Yes, ma'am.
Okay. Kana, what is your name?
Selvak.
Selvak. Which class you are in?
11th.
11th standard, okay. Janani, Rohan, Selvak. Am I right?
Yeah, ma'am.
Okay.
Yes, ma'am.
Kana, how you guys are comfortable in organic chemistry? Because all the 4 students are new to this class, and actually I've discussed most of the fundamentals in previous classes. So that is why I've started with the numerical now, or the problem now. But if you guys are facing any difficulty, please let me know, so that I'll discuss few concepts, and after which we'll discuss a couple of questions. If you guys are comfortable, then we can go for problems. But if you guys are not comfortable with the concepts, please let me know. We'll start with any concept first.
மேம் நான் விஸ்வாங்க மேம். எனக்கு வந்து கொஞ்சம் கான்செப்ட்ஸ் கொஞ்சம் சொல்லிட்டீங்கன்னா நல்லா இருக்குங்க மேம்.
ஓகே, ரைட். கண்ணா, இப்போ நம்ம அந்த தமிழ் இங்கிலீஷ்ல மாத்தி எடுத்தா உங்களுக்கு ஓகேவா?
மேம் அதெல்லாம் ஒன்றும் பிரச்சனை இல்லை மேம். இங்கிலீஷ்ல சொல்றது ஒன்றும் பிரச்சனை இல்லைங்க மேம். நான் கொஞ்சம் கேப்பபிள் பண்ணிப்பேன் மேம். ஓகே. அந்த டேர்ம்ஸும் நான் இப்போ இந்த எக்ஸாக்ட் இந்த கார்போகேட்டியான் கார்பானியன்லாம் முடிஞ்ச அளவுக்கு நான் தமிழ்ல சொல்றேன். அது ஆனா ஜெனரலா சொன்னா உங்களுக்கு புரியும் தானே விஸ்வா? ஆமாங்க மேம். கார்பன் கேட்டையான்னா கார்பன் நேரங்கி அதெல்லாம் ஓகே தாங்க மேம். ஓகே, ரைட். அதுல ஏதாவது ஸ்பெசிஃபிக்கா ஏதாவது தெரியல, ரொம்ப வித்தியாசமா இருந்ததுன்னா சொல்லுங்க. அதுல ஏதாவது தமிழ் எனக்கு தெரிஞ்சா சொல்றேன். சரிங்களா? ஓகேங்க மேம். ஓகேங்க மேம். ஓகே. Thank you மேம். ஓகே. Kana, how about rest of the students? So shall we see some raw fundamental of organic chemistry? Shall we?
Sure, ma'am.
Okay, fine. Okay. Because you guys should not feel uncomfortable, because since I've started with a problem, if you don't understand the problem and if you don't understand the concept, and starting with a problem is completely meaningless. Is the screen visible now? Okay. So we'll start with raw fundamental of organic chemistry. Okay. So this will be definitely useful for your 11th and 12th standard. Anyways, in 12th standard, we have so many organic chapters. So for which definitely fundamentals, organic fundamentals are very important. So I'll start with a very basic fundamentals in organic chemistry. Okay. So, what is carbon, valency of carbon, what is hydrocarbon, what is functional group, and all that, right? What is, could you please tell me the atomic number of carbon?
16, madam.
Correct. So, now we're going to start with organic chemistry. Karima Vedial. So, organic chemistry is nothing but we'll be only studying about carbon and carbon containing compounds. So, understanding the atom called carbon is very, very important. As far as carbon is concerned, the atomic number is 6. Anuyan, 6. So, electronic configuration is 1s2, 2s2, 2p2, right? So this is the second shell is the valency shell, right, Kana? So this is the outermost shell. In outermost shell, how many electrons we have? In outermost shell, how many electrons we have? Yes, very good. We have 4 electrons. Usually, carbon atom will use these 4 electrons to form any chemical bond. Okay. So, I'm going to represent these 4 electrons around this carbon atom. Listen, I have carbon atom. So, the symbol of carbon is C. And I'm going to distribute this 4 electrons around this carbon atom. So, how I'm going to distribute is, I'm going to represent each electron by dot. So I have 4 electrons. So I have to put 4 dots around this carbon atom. I have 4 sides, left, right, top and bottom. So 1, 2, 3 and 4. That's it. One round was over and we have filled all the 4 electrons. That's it. So around this carbon atom, we have 4 unpaired electrons. Atom is alone, right? It is not paired. So this is unpaired electrons. And usually carbon atom will use these unpaired electrons to form a chemical bond. So carbon got 4 unpaired electrons. So carbon can form 4 chemical bonds. Okay. So valency. Since carbon can form 4 chemical bonds, the valency of carbon is 4. Okay, combining capacity is 4. We'll check for oxygen. Since we have found for carbon, let us see, is it possible for us to check it for oxygen? What is the atomic number of oxygen? Atomic number of oxygen. Yes, very good. Electronic configuration. Yes, Janani, it is 8. Very good, Kana. So electronic configuration is 1s2, 2s2, 2p4. Very good. So which is the valency shell? Again, second shell is the valency shell. Whenever I'm asking for valency shell, you have to check for the principal quantum number, முதன்மை quantum in. So principal quantum number, you have to check which is the largest principal quantum number. So second shell is the highest value. So this is the valency shell. In this valency shell, we have 6 electrons, right? So I'm going to distribute all the 6 electrons around this oxygen atom. 1, 2, 3, 4. Now one circle was over, right? One cycle was over. So 4, 5 and 6. That's it. So how many unpaired electrons we have? Only 2. So basically oxygen can form only 2 chemical bonds. So valency of oxygen is 2 and valency of carbon is 4. Inai Dhiran. valency of carbon is 4 and valency of oxygen is 2. Okay, this is how we have to find the valency or the combining capacity of any atom. Could you please tell the valency of hydrogen atom? How many chemical bond can this hydrogen atom form? Yes, 1, because the atomic number of hydrogen is 1 and the electronic configuration is 1 as 1 and the only electron in the valency shell is 1. So hydrogen can form only one chemical bond. That's it. Right. So we understood about the atomic number, how to write, the electronic configuration and how to find the valency. That's it. Now we'll move on to organic compound. So this is my carbon, and we know carbon can form 4 chemical bonds, right? So to satisfy the valency of each bond, I'm going to have another carbon here. And to satisfy the valency of this bond, I'm going to have another carbon. And I have another carbon here. See, here we have empty bonds, right? We have to fill these empty bonds also. If I'm trying to fill this empty bond using carbon atom, then again this carbon atom will have 3 more chemical bonds, right? So instead of carbon, could you please tell me any atom with valency 1? Any atom with valency 1? Hydrogen. So rest of the bonds are satisfied using hydrogen atom. So here I have carbon atoms and the valency of all the carbon atoms are satisfied by another carbon atom or hydrogen atoms, right? That's it. So in this compound, how many types of atoms we have? We have carbon and hydrogen. And which atom is the backbone? Which atoms are the backbone of this molecule? Carbon. So in a molecule, if carbon atoms are the backbone, then that molecule is called organic molecule, or that compound is called organic compound. So in this compound, carbon atom was the backbone. So this is the organic compound. In this organic compound, we have only carbons and hydrogens. So if any organic compound contains only carbon and hydrogen atoms, then that kind of organic compound is called hydrocarbon. So hydro means hydrogen. So we have only just carbon and hydrogen atoms. That is why that organic compound is more specifically called as hydrocarbon. So in organic chemistry, one whole chapter is about fundamentals, only the fundamentals of organic chemistry. And second chapter is about hydrocarbon. Okay, fine. So now we'll understand about hydrocarbon. I'm going to write few hydrocarbons and I want you guys to tell me the difference between those compounds. See, this is my hydrocarbon, right? This can also be written as this is my carbon and this is attached with 3 hydrogens, right? So CH3. And this carbon is attached with one more carbon here. And this carbon is attached with 2 hydrogens, CH2. And again CH2. Again, this is CH3. This is the condensed formula. Normally, this is how the organic molecule will be. But whenever we are writing the compound in any note, we'll be representing like this. This is called condensed formula of organic compound, right? So this is one hydrocarbon. Carbon, double bond carbon, single bond carbon. So to satisfy the valency of this carbon, I should have 3 hydrogens. to satisfy the valency of this carbon. Already left side I have one chemical, left side I have two chemical bonds, right side I have one chemical bond, and one more bond, one more valency has to be filled. So with hydrogen and two hydrogen here. Can I listen here? I've written different types of hydrocarbons on the board, right? All the compounds are hydrocarbons. Could you please tell me the difference between compound A and compound C? A and C. What is the difference between compound A and C? Yes. So as Vishwa said, the basic difference between compound A and C is number of carbon atoms. In compound A, we have 4 carbon atoms, right? And in compound C, we have 3 carbon atoms. Okay. What is the difference between compound B and C? Compound B and C. What is the difference between compound B and C? Yes. The difference is number of chemical bonds between carbon atoms. So in our regular life, we are using hydrocarbons, but we are using different types of hydrocarbons in our regular life. The basic difference between one hydrocarbon and another hydrocarbon is number of carbon atoms as in first and third compound, and number of chemical bonds between carbon atoms as in second and third compound. Okay, so the basic difference between two hydrocarbons are two things. One is number of carbon atoms, another one is number of chemical bond between carbon atoms. So whenever you're naming any hydrocarbon, always you have to mention number of carbon atoms and number of chemical bonds between carbon atoms. Number of carbon atoms are technically called as alk, ALK. Whenever you see the term alk, then you have to understand in that place we have to represent number of carbon atoms. And as far as number of chemical bonds are concerned, if we have only single bond, then we have to add the term ANE. Yes, Kana, any doubt? Any doubt? Someone raised your hand, right? Okay. If we have double bond in the hydrocarbon, then you have to end the name with ENE. If there is any triple bond, then you have to end the name with ENE. Okay. Fine. So we'll see what this ALK represents. Generally, ALK represents what? Generally, ALK represents what? Number of carbon atoms, right, Kana? So if we have only one carbon, then the ALK should be Neet. If we have two carbons, then ALK should be ETH. If we have 3 carbons, then ALK should be prop. If you have 4 carbons, then what is ALK?
Bute.
Very good, it is bute. 5 carbons?
Pent.
6.
Hex.
7 carbons?
Hept.
Very good, hept. 8 carbons?
Opt.
9 carbons? Non. 10 carbons.
Deck.
That's it. Now we'll use these terms to name all the three organic compounds here. As far as first compound is concerned, we have 4 carbons. So alkys bute. And all the 4 carbons are connected through single bond. So if it is single bond, we have to use the term ANE. So butane is the name of this compound. Similarly, could you please name this compound, Kana? This one.
Propene.
Very good. We have 3 carbons, so it is prop. And we have double bond between these 2 carbon atoms, so it is propene. What is the name of this compound?
Propane.
Very good. It is propane. CH, triple bond CH.
Ethane.
It's ethane.
Ethine. Very good. That's it. So the basic difference between hydrocarbons are number of carbon atoms and number of chemical bonds between carbon atoms. Okay. That's it. Now, name of this compound is propane. I have 3 carbons and all the 3 carbons are connected through single bond. What I'm going to do is, instead of 1 hydrogen here, we have 3 hydrogens, right? Instead of 1 hydrogen, I've removed 1 hydrogen, right? Initially, I had 3 hydrogens to that carbon. I've removed 1. So 1 bond is empty. To this empty bond, I'm going to add 1 special group or 1 special atom, which is different from your carbon and hydrogen. It can be any atom apart from carbon and hydrogen, or any special group of atoms. Fine. So what will happen is, initially we had propane, right? Each organic molecule will have their own set of physical and chemical properties. It will have their own characteristics. But as far as propane is concerned, propane also got its own physical and chemical properties, right, Kana? Physical properties in the sense, it will have a melting point, boiling point, solubility, and all that. It is specific for propane. But as far as this system is concerned, I've replaced 1 hydrogen with 1 special group. Now, complete physical and chemical properties were changed based on this new group. Now, this group is called functional group. Initially, the compound was propane, and propane got its physical and chemical properties. But in propane, one of the hydrogen was replaced with special group, and now all the complete physical and chemical properties were changed based on that special group, and that special group is called functional group. Okay. Vinay Sayal Togudi. And we have different types of functional groups, right, Kana? Could you please tell me a few examples of functional groups you have studied in your 11th standard, or at least in your 10th standard?
Aldehyde.
Yes, very good. Aldehyde. Yes, Janani?
Ma'am, alcohol.
Alcohol. Very good. Mushkan, any functional groups you know?
Carboxylic acid.
Carboxylic acid. Janani told one more functional group, I guess.
Ma'am, ketone.
Ketone, yes. Aldehyde, ketone, carboxylic acid, alcohol, ether, amine, all these were functional groups. Right. Fine. So, Kana, listen here. Initially, it was propane. But in propane, I've removed one hydrogen, right? Then it is not propane. I've removed one hydrogen, no? So you have to represent it like prop vial. Whenever I'm using the term vial, then you have to understand that I've removed one hydrogen already. So propyl is nothing but I've removed one hydrogen from propane. So to this propyl, I have a functional group. Okay. Instead of prop, generally what this prop represents, number of carbon atoms, right, Kana? Instead of this prop, generally I can write it as alk. So this is alk, and from that alkane I've removed one hydrogen, so it is alkyl group. So this alkyl group is attached with a functional group. And generally this alkyl group can be represented with an alphabet which is capital R. So capital R is attached with a functional group. So whenever you're writing any functional group, in that functional group, definitely you would have attached one R, right? R group is nothing but an alkyl group, which is basically a hydrocarbon in which you would have removed one hydrogen. Okay, fine. So this is my alkyl group. This alkyl group is attached with a functional group. Now we're going to see different types of functional groups. I have my alkyl group, and this alkyl group, initially it was alkane, and in which I've removed one hydrogen. No, instead of that hydrogen, I'm going to add an atom. Okay. I want you guys to tell me how many unpaired electrons and how many paired electrons were there. See, how you told for oxygen. Oxygen got two unpaired electrons, right, Kana? These unpaired electrons are called bond pair, and usually these bond pairs are used to form chemical bond. And these paired electrons are called lone pair. Okay, so oxygen got two lone pairs and two bond pairs, right, Kana? This is two lone pairs and this is two bond pair. Similarly, I want you guys to tell me for each atom, which I'm going to write here. Fluorine. As far as fluorine is concerned, how many lone pairs and how many bond pairs will be there, and how many chemical bond a fluorine atom can form? Because I'm going to replace that hydrogen with fluorine. You guys getting my point? I want you guys to tell me how number of lone pairs and bond pairs around fluorine atom. So first you have to know the atomic number of fluorine, electronic configuration, valence electrons, and you have to distribute all those valence electrons around fluorine, and you have to find how many pairs and unpaired electron. விஸ்வா அது அணு என்னங்களா 11 என்னக்குன்னா
மேம் பாண்ட் அண்ட் லோன் பேர் பண்ணக்கூடிய பேர் லோன் பேர் மென்ஷன்
இல்ல சாமி அவ்வளோ வராது.
ஓகே ஓகே.
அணு எண் எவ்வளோ ஃப்ளூரனுக்கு? Atomic number of fluorine is 9. Yes, it is 9. So electronic configuration is 1s2, 2s2, 2p6, 2p5. That's it. So the valency shell is second shell. In second shell, how many electrons we have? How many electrons we have? 5 plus 2, 7 electrons. So yes, so I'm going to distribute the 7 electrons around fluorine. I can start from anywhere. I'm going to start from here. 1, 2, 3, 4, 5, 6, 7. That's it. So I have one bond pair and 3 lone pairs, which means fluorine can form only one chemical bond, right, Kana? So that chemical bond is with alkyl group, and rest of the lone pairs should be here. That's it. And this is a kind of functional group. And name of this functional group is fluoride. Okay. Name of this functional group is fluoride. That's it. Now I want you guys to tell me the number of lone pairs and bond pairs for chlorine. How many valence electrons this chlorine atom got? Yes, it is 7. Very good. You know what? It is very easy to find the valence electrons without even knowing the atomic number, without even writing the electronic configuration. We can understand, I mean, we can find the number of valence electrons. How to do that? How to find the valence electrons without knowing the atomic number? Basically, if you know the position of that element in the periodic table, then it is very easy for us to find the number of valence electrons. Okay, Kana. Listen, how many groups we have? How many groups we have in periodic table? Togadigal. Yes, Rohan is right. 18 groups. So in that, I'm going to write only S block and P block. So this is S block, which is group 1 and group 2. Togudi 1, Togudi 2. So group 1 and group 2 were S block elements. Group 13 to group 18 is P block. Fine. As far as group 1 is concerned, what are all the elements we have in group 1? Lithium, sodium, potassium, rubidium, cesium, francium. This is second period. This is third period. This is fourth period. Fifth, sixth, seventh period. Okay. So we have 7 periods and 18 groups. Right, Kana? Okay. So what are all the elements present in second group? Beryllium, magnesium, calcium, strontium, barium, radium. Group 13 is boron, aluminium, gallium, indium, thallium at least 6th period we have to know. And as far as group 14 is concerned, at least tell me the first element, which is very easy. The hero of organic chemistry.
Carbon one.
Carbon. Silicon, germanium, tin, lead, nitrogen, phosphorus, arsenic, antimony, bismuth, oxygen, sulfur, selenium, tellurium, polonium. 17th group. Very easy. Are halogens. Fluorine, chlorine, bromine, iodine, astatine. Very easy. 18th group. The very first element is helium, which is in first period of periodic table. Next is, which is the 10th element in periodic table, Kana?
Neon one.
Neon. Very good. Next is
Argon.
krypton, xenon, and radon. That's it. See, the elements which is present in group 1 will have only one electron in its valency shell. So you need not write the electronic configuration. If you know that element is present in first group, then obviously that element will have 1 electrons in its valence shell. The elements which are present in second group will have 2 electrons in its valence shell. Okay. As far as 13th group elements are concerned, you have to check for this number which is present in one's place. 13. The number which is present in one's place is 3. So elements in the 13th group will have 3 electrons in its valency shell. So 14th group elements will have 4 electrons in its valency shell. So elements which is present in 15th group will have how many electrons? How many valence electrons?
5, madam.
5. So 16th group elements will have 6 electrons. 17th group elements will have 7 electrons. 18th group elements, except helium, all the elements will have 8 electrons. Only helium will have 2 electrons. That's it. Now, we saw about fluorine, right? Now, I asked for chlorine. Chlorine also, it is in 17th group, so 7 electrons. So, it is very similar to our fluorine. So, all the halogens will have similar electronic configuration and similar loose dot structure, similar number of bond pairs and lone pairs. So, similar to our fluorine, chlorine also will have equal number of electrons in its valence shell. So this is the structure. So this is fluoride, this is chloride, this is another functional group. Next is bromide. Next is iodide. Generally, this can be expressed as halide. So this is the functional group. So this is the first functional group, which is halide. Okay. Next functional group, I have an alkyl group. So one hydrogen is missing, right? So to this empty bond, I'm going to have one oxygen atom. How many lone pairs and how many bond pairs we have for oxygen? How many lone pairs and bond pairs for oxygen? We saw that already. 2 bond pairs and 2 lone pairs, right? So one bond pair, a bond pair is attached with this R group. One more bond pair is empty here. 2 lone pairs here. Usually lone pairs will not involve in any bond formation. Now we have one unpaired electrons. Now this oxygen will use this unpaired electron to combine with a hydrogen atom. That's it. Could you please tell me the name of this functional group? Jenny? What is the name of this functional group? Yes, it is alcohol. Yes, Kanna. So here I've written the proper structure of alcohol where I've represented all the lone pairs and all. But generally, most of the cases in books, they'll not represent this lone pair. But that doesn't mean that oxygen doesn't have that lone pairs. That does, but mostly they'll not represent it. So this is how they'll be writing the functional group of alcohol. Next. Similarly, here this electron, we have one unpaired electron. No, this unpaired electron is again combining with another R group. What functional group is this? Just the oxygen. Left side we have one R group and right side we have one R group.
Ether, ma'am?
Yes, it is ether. Ether. Here I have an alkyl group. This empty bond is satisfied with carbon atom, but we know carbon can form 4 chemical bonds. So here 2 bonds are with oxygen. So oxygen got 2 lone pairs and 2 bond pairs, but 2 bond pairs are connected with carbon itself. Now I have one unpaired electron to this carbon, and this unpaired electron is combined with another hydrogen. And now what functional group is this? RCHO. This can also be written like this. Aldehyde. R C double bond O. Now,
Aldehyde.
yes, aldehyde. And here this electron is satisfied with another R group. So what functional group is this? Ketone. Ketone. Next. R C double bond O. We have one unpaired electron here. This unpaired electron forms a chemical bond with one more oxygen. So this oxygen got two lone pairs and two bond pairs. One bond is with carbon and one bond is empty now. This electron is combined, is again sharing it with hydrogen. What functional group is this? RCOOH, a very famous one. You told me already.
Carboxylic acid.
Yes. RC double bond O oxygen. Instead of this hydrogen, I have one more R group, which is RCOOR. It is ester. Ketone. Kana, could you please tell me the number of lone pairs and bond pairs for nitrogen? Number of lone pairs and bond pairs for nitrogen. Nitrogen is in 15th group. So how many nitrogen? How many valence electron this nitrogen got? Since nitrogen is in 15th group, nitrogen got 5 valence electrons. And I want you guys to tell me the number of lone pairs and number of bond pairs.
2 lone pair and 1 bond pair, man.
Come again, Kanna. In order to solve
2 lone pair, man. 2 lone pair, man. 1 bond pair, correct, man?
எவ்வளவு வேலன்ஸ் எலக்ட்ரான் இருக்கு?
5 இருக்குதுங்க மேம்.
5. ஓ nitrogen 5 electrons are 1 2 3 4 5. So this is lone pair and this is bond pair. So we have 3 bond pairs and 1 lone pair. Okay now. So what is the combining capacity or how many chemical bonds this nitrogen atom can form? இணைதிறன். Nitrogen இணைதிறன். What is the combining capacity of nitrogen? How many chemical bonds this nitrogen atom can form? Yes, it is 3 because nitrogen got 3 unpaired electrons. So this nitrogen got 1 lone pair and 3 bond pairs. One is with R group. Here we have two more bond pairs, right? Now this electron forms a chemical bond with hydrogen and this electron forms a chemical bond with hydrogen. So this is basically RNH2. So what is the name, Kana? What is the name of this functional group? Easy. It starts with A. Yes, it is amine. Very good. Carbon, RC double bond O, nitrogen, and this nitrogen got 2 hydrogen. Any guesses? RC double bond O and H2. Any guesses? This also starts with A. Amide. Amide. Okay. One last functional group, okay? One last functional group. Definitely that is not new to you. but I'll write the proper structure and I want you guys to tell me the name of that functional group. It's very easy. I have R group where one bond is empty. I have nitrogen atom. We know nitrogen atom got 3 bond pairs and 1 lone pair, which means nitrogen can form 3 chemical bond basically. If this nitrogen have to form one more chemical bond, that is fourth bond, at that time this nitrogen will use its pair of electron to form one more chemical bond. Normally it will not happen, but whenever this nitrogen is forced to form one more chemical bond, that is fourth bond, then nitrogen will use its lone pair of electron. So that kind of scenario is going to happen here. Here this nitrogen double bond O, single bond O minus. So how many chemical bonds this nitrogen got? 1, 2, 3 and 4, which means nitrogen used its lone pair of electron to form a chemical bond. So this nitrogen got 1 positive charge. And here this oxygen can form 2 chemical bonds, but here this got only 1 bond here, right? So this got 1 negative charge on this oxygen. So what functional group is this? This is the proper structure. I'll write a normal structure also. This you have seen in your book.
Nitro.
Nitro. That's it, Kana. So we have seen what is functional group and different types of functional groups. Okay. Any doubt? Now we want to understand the hybridization of carbon. We want to see hybridization of carbon. Inakalappu. Hybridization of carbon. This you would have studied in your the chapter called chemical bonding, and also in organic chemistry. As far as organic chemistry is concerned, you will be studying the hybridization of carbon only. It is very easy. Here, nothing complicated. Just by seeing the carbon itself, we can find the hybridization of that carbon. Usually, carbon will have only 3 hybridizations. How many chemical bonds a carbon atom can form? How many chemical bonds a carbon atom can form? 4, right? In any organic compound, if you check for one carbon atom and that carbon atom is connected with 4 single bond, then the hybridization in a kalappu, hybridization is sp3. That's it. If carbon got 1 double bond, then to satisfy the valency, how many chemical bonds we need? 2 more bonds, right? If 2 more bonds are single bond, then the hybridization is sp2. Carbon got 1 triple bond and 1 single bond. Or if carbon got 2 double bonds, then the hybridization of carbon is sp. That's it. This is how you have to find the hybridization. Okay. If the hybridization is sp3, then what is the geometry, Kana? Vadivam. Geometry. Tetrahedral. If it is sp3 hybridized carbon, the geometry is tetrahedral. Okay. Non-Mugi. sp2. If it is sp2, if the hybridization is sp2, then what is the geometry? Janani, you have studied in your 11th standard, Kana, in chemical bonding. Any idea? Trigonal planar or triangular planar. If the hybridization is sp,
linear ma'am.
very good. Mushkan,
Ma'am,
very good.
நான்
Yes, Kanna.
நான் பேசுனதெல்லாம் இப்பதான் மேம் நான் மியூட்ல போட்டுட்டு இருந்தேன் மேம். நான் பேசுனது உங்களுக்கு கேட்கல மேம் எதுவும்.
ஆமா கண்ணா கேட்கல, இப்பதான் வாய்ஸே கேக்குது. So the geometry is linear. பரவாயில்ல, ஞாபகம் வச்சிருக்கீங்களே?
அந்த நோட் முன்னாடி வச்சிருக்கேன் மேம்.
Okay, very good. That's it. Next is percentage of S character.
25 மேம்.
Yes, very good, Kanna. So for sp3, the percentage of S character is 25%. Let us understand how this is 25%. Listen, sp3 basically, Kanna, listen here. As far as S subshells are concerned, if S subshell is concerned, we have only one orbital, which is S. As far as P subshell is concerned, we have how many orbitals?
3.
3. So, if the hybridization is sp3, then one s orbital and all the 3 orbitals will get involved in hybridization. இனக்கலப்பு, இந்த 4 orbitals ஒண்ணா mix ஆயிரும். சரிங்களா? So, here we have 4 atomic orbitals, 1, 2, 3 and 4. If all the 4 atomic orbitals are involving in hybridization, then we'll end up with hybridized orbitals. How many hybridized orbitals we have? How many atomic orbitals involved in hybridization? It was 4. So we'll end up with 4 hybridized orbitals. And all the 4 orbitals will have same energy, in fact same name. So name of this orbital is sp3. sp3. Okay, so initially before hybridization, this orbital will have 100% s character and all these orbitals will have 100% p character. But each orbital in this hybridized system will have the character of both S and P, right, Kanna? So we'll have the character of both S and P. So now we have to understand how many, how much percentage of S character and P character were there. How to do that? Totally 100% character. How many orbitals were involved in the hybridization? இனக்கலப்புல எவ்வளவு orbitals involve ஆயிருக்கு? It was 4.
4,
right? So 100 divided by 4 is 25%, which means each orbital is contributing 25% for the character. So here, as far as S is concerned, it is contributing 25%. As far as P orbitals are concerned, we have 3p. So each P is contributing 25%. So 75% is P character. Okay, here we are talking about just P character, S character. So percentage of S character is just 25%. That's it. Could you please tell me the percentage of S character in sp2 hybridized carbon? Percentage of S character in sp2 hybridized carbon, totally 100, and number of orbitals involved in hybridization is 1s and 2p orbitals. So 100 divided by 3.
33.
Yes, 33.33%.
Yes,
So linear
percentage ma'am.
Yes, 50%. Totally 100, and the number of orbitals involved in hybridization is just 2, S and P. So 100 divided by 2 is 2. 100 divided by 2 is 50. So each orbital is contributing 50% to the character. That's it, Kanna. Next. Bond angle. Yes, Vishwa?
மேம் அப்ப இனக்கலப்புல கலந்துக்காத அந்த ஆர்பிட்டல பர்சன்டேஜ் கால்குலேட் பண்றதுக்கு எடுத்துக்க வேண்டியது இல்லையா மேம்?
எடுத்துக்க வேண்டியது இல்ல. அதாவது இவங்க 2 பேரும் சேர்ந்து தானே நம்மளுக்கு இங்க கான்ட்ரிபியூட் பண்ணிருக்காங்க. அப்ப மிக்ஸ் ஆகாதத கணக்குல எடுத்துக்க வேண்டியது.
ஓகே மேம்.
bond angle. If it is sp3, bond angle is 109.5. 109.5. If it is sp2,
120.
120.
very good, 120. If it is sp, easy.
180.
180.
பிணைப்பு கோணம் 109.5 degree, 120 degree, 180 degree. பிணைப்பு கோணம், bond angle. Right. Next is carbon carbon single bond, carbon carbon double bond, carbon carbon triple bond. Kana, as the number of chemical bonds between the atom increases, what is happening to the bond length?
Decreases.
Yes. So as the number of chemical bond increases, the distance between the atom decreases. So technically, the number of atoms between the, number of chemical bonds between the atoms is called bond order. Bond order. Okay. And a bond order is basically the number of chemical bonds between two atoms. Bond order, or it is also called as bond multiplicity. And it is inversely proportional to bond length. Okay, as the number of chemical bonds increases, distance between the atoms decreases. Okay, any doubt?
No, ma'am.
Okay, Kana. Now I'll give you a structure and I want you guys to tell me the hybridization of each carbon. Okay. Here, this is my carbon, and this carbon got one double bond. So to satisfy the valency of this carbon, I should have two hydrogens. And for this carbon, I need only one hydrogen. For this carbon, I need only one hydrogen. For this also, I need only one hydrogen. This carbon need two more hydrogens. And this is already satisfied. And to satisfy the valency of this carbon, one hydrogen I want. Okay. See, this organic compound got how many carbons? 1, 2, 3, 4, 5, 6, 7. So for all the 7 carbons, we can find the hybridization. Okay, it is very easy. Right. So as far as this carbon is concerned, this got one double bond and rest of the bonds were single. So what is the hybridization? One double bond, and if all the bonds are single, one double bond and two single bonds, then what is the hybridization?
sp2, ma'am.
Very good, sp2. What is the hybridization of this carbon? sp2. What is the hybridization of this carbon?
sp, ma'am.
sp. How about this carbon?
sp, ma'am.
sp. For this carbon?
sp2, ma'am.
Around this carbon, we couldn't see any double bond or triple bond, which means we got only single bond over there. So it is sp3. Yes, very good, Rogan. And how about this carbon? Yes, Mushkan.
sp2, ma'am.
Very good, it is sp2. This one?
sp2, ma'am.
That's it. That's it. Any doubt? Okay. Now we're going to get into another important topic. See, organic compound is different from our inorganic compound because organic compounds are usually a bigger one, a complicated one too. See, here itself, we have so many number of carbon atoms and we have so many chemical bonds, and to satisfy the valency, I've calculated hydrogen also. Whenever we are writing or representing any organic compound, we cannot write all the atoms. It is very difficult. So we have an alternative option also. Just by drawing the bond lines, we can represent any organic compound. We will not mention any carbon atom or hydrogen atom. We'll be just drawing the bond lines. If suppose, if apart from carbon and hydrogen, if we got any heteroatoms or if we got any different atoms apart from carbon and hydrogen, then we'll mention only that atom there. Okay, see, a very classic example. I'm going to write the structure. That too, I'm going to write the bond line representation, which is a very famous one. You would have studied in your 10th standard itself. What compound is this?
Benzene.
Yes, it is.
Benzene.
It is benzene. See, here I've just drew the bond lines. I didn't even mention one atom there, but you know the name of the molecule, right? It is benzene. So this is called bond line representation. Bond line representation. Okay, so this is bond line representation. I'm going to convert this bond line representation into a normal molecule. Okay, it is very easy. See, here we have to check how many bends there. Wherever we have bend or wherever we have terminal, you should understand that at that point we have carbon atom. See how many bends here? 1, 2, 3, 4, 5, and 6. So we have 6 bends. So I have 6 carbon atoms. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So between first and second carbon, we have only one bond. Okay. Between second and third carbon, we have double bond. Okay. Third and fourth carbon, I have single bond. Between fourth and fifth carbon, I have double bond. Fifth and sixth carbon, I have single bond. Sixth and first carbon, I have double bond. That's it. So I've counted number of carbon atoms and I've written the carbon atom. And I've saw the number of bonds between carbon atoms. I've drew the number of bonds. Now, finally, we have to satisfy the valency of each carbon. As far as this carbon is concerned, we have 1, 2, 3 bonds. So to satisfy the valency, how many chemical bonds we need? What is the valency of carbon, Kanna? Generally, we need 4 chemical bonds. Already we have 3. So fourth bond should be here and it should be connected with hydrogen atom. Why hydrogen? In bond line representation, there is no mention, which means that carbon's valency was satisfied with hydrogen. If it was satisfied with any other atom, then they would have represented that. But I didn't represent any atom over there, which means there the carbon's valency was satisfied only using hydrogen atom. And how about this carbon? Here also we need one more bond with hydrogen, with hydrogen, with hydrogen, with hydrogen, and with hydrogen. That's it. So this is the actual structure of benzene, and this benzene got 6 carbons and 6 hydrogen. This is the molecular formula of this compound. That's it. Okay. If suppose this is benzene, you know, right? Here, if this carbon got one hydrogen. No, instead of one hydrogen, if I have chlorine, then it will be like this only. Okay, which means here we have no hydrogen. Instead of hydrogen, a chlorine was substituted. Okay, any guesses? Could you please tell the name of this compound? This is benzene.
Chlorobenzene.
Very good, it is chlorobenzene. Right. Also, whenever we have single bond, then that is a sigma bond. Whenever we have double bond, one bond is sigma and one bond is pi. Whenever we have triple bond, one is sigma and rest of the bonds were pi. Okay. So could you please tell me how many sigma bonds and pi bonds are there in benzene? How many sigma bonds and pi bonds are there in benzene? Six sigma bonds and three pi bonds. Janani's answer is 6 sigma and 3 pi bonds. Okay, we'll check Janani. Yes. Okay, listen. Here we have double bond. So this is one of the bonds is pi. So this is pi bond, this is pi bond, this is pi bond. So we have 3 pi bonds. This is right. Now we have to check for sigma bonds. Shall we? Shall we check now? This is bond number 1. This is 2. This is 3. Here in double bond, one of the bonds is sigma, another bond is pi. So this is sigma bond, right? So 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have 12 sigma bonds. You getting my point? Any doubt? Okay. Janani? Do you have any doubt, Kanna?
No, ma'am.
Okay. So whenever the bond line representation is given, and if they're asking us to find the number of sigma and pi bonds, please convert that bond line representation into a normal molecule, then count number of sigma or pi bonds. Else you'll miss most of the sigma bonds. Okay. So whenever the bond line representation is given, please convert that into a normal molecule to count for number of sigma and pi bonds. Is that clear? Fine. Now I want you guys to tell me among sigma bond and pi bond, which is a stronger one? Among sigma and pi bond, which is a stronger one? Sigma. Sigma is the stronger one. Right. Now, I'm going to give you a molecule where I'm going to give you the bond line representation. Okay. The challenging part is I want you guys to tell me what functional group is there, and also finally you have to tell me how many sigma bonds and pi bonds are there. Okay. You have to do 2 jobs. One is you have to check for the functional group, and second one is you have to find the number of sigma and pi bonds. Okay. Okay, fine. Yes, Kana. I want you guys to tell me what are all the functional groups present there. Please do only that. Now, what are all the functional groups? Could you please tell me how many functional groups are there? Forget about the type. Tell me number of functional groups. Vinay Togudi.
மேம் ஆல்கஹால் ஒன்று இருக்குதுங்க மேம்.
ஓகே. எங்க சாமி இருக்கு?
லாஸ்ட் கார்பன்ல ரைட்ல லாஸ்ட் கார்பன்ல இருக்குதுங்க மேம்.
லெஃப்டா ரைட்டா கண்ணா?
ரைட்டுங்க மேம்.
இதுங்களா?
ஆமாங்க.
That was a good try, but that is not alcohol. நல்லா பாருங்க சாமி.
OH தானே மேம் அது?
OH தனியா இல்லைங்களே.
Ma'am, is it ether?
Which is ether, Rohan?
The right side one.
No, it's not ether. But the beauty is this compound got alcohol and ether as well. Unfortunately, this is not ether. This is neither ether nor alcohol. But it is a very famous functional group.
Oh, carboxylic acid.
Yes, it is. Yes, it is. Because this is carbon, and this carbon is attached with oxygen through double bond. And this is the same carbon is attached with OH. Okay. So this is carboxylic acid. So this is carboxylic acid. Vishwa, this compound got alcohol. But see where alcohol is.
மேம் லெஃப்ட் சைடுங்களா?
It is just OH. So this is alcohol. It is not connected with any C double bond O. It is just OH. So this is alcohol.
ஓகே மேம், இப்போ புரியுதுங்க.
It is just oxygen. What functional group is this? It is just the oxygen.
ஈத்தருங்களா மேம்?
அவ்வளவுதான். Ether. See, it is just the oxygen. Right, left side and right side we have R group. So it is ether. Next. This is C. Double bond O. So this carbon is attached with oxygen through double bond. Left side we have some R group. Right side we have some R group. C double
Ketone.
bond. Very good, it is ketone. That's it. So here we got 4 different functional groups. That's it, Kana. So I'm going to give you one activity. For this compound, I want you guys to find number of sigma bonds and number of pi bonds. So to find that, you have to convert this into a normal molecule and count for number of sigma and pi bonds. Okay. Next is, I want you guys to tell me the hybridization of each carbon. Okay, we have so many carbons here, and for all the carbons you can find the hybridization. So find the hybridization of each carbon. Okay, is it possible? So anyways, I'll send you the notes, Kana. So anyways, you'll be having this page also. So use this structure, and I want you guys to tell me the hybridization of each carbon and check for number of sigma and pi bonds. Okay. So today we have discussed carbon, atomic number, electronic configuration, valency, combining capacity, and hydrocarbons, the difference between different hydrocarbons, bond end representation, what is functional group, different types of functional group, and all that. Okay. So in next class, we'll be talking about hydrocarbons, how to prepare different types of hydrocarbons. So we'll get into the topic called hydrocarbon. and we'll see how to prepare each type of hydrocarbon, different types of preparations and different types of chemical properties of hydrocarbon. Okay, and also we'll be seeing physical properties of organic compounds. Okay, rest of the things we'll talk in next class, Kana. If you have any doubt, please ask me. Else, we'll wind up the session. Thank you, Rohan. Thank you so much.
மேம் நீங்க கெமிக்கல் பாண்டிங் ஆல்ரெடி நடிச்சிட்டீங்களா மேம்?
இல்ல சாமி இல்ல.
ஓகே ஓகே மேம். ஓகே மேம்.
நீங்க இப்பதானே கண்ணா 11th ஸ்டாண்டர்ட்?
ஆமாங்க மேம்.
ஓகே, நம்ம மறுபடியும் எடுக்கலாம் கண்ணா, எடுப்பேன், கண்டிப்பா எடுப்பேன்.
ஓகே, கிளாஸுக்கு புதுசா இருந்திருக்கிறதுனால ஒரு கன்ஃபர்மேஷன் கேட்டேன்.
ஓகே சாமி, ஓகே.
ரொம்ப தேங்க்யூ மேம், யூஸ்ஃபுல்லா இருந்தது மேம் கிளாஸ்.
தேங்க்ஸ் கண்ணா, நன்றி.
லெஃப்ட் ஆயிக்கலாம்ல மேம்?
தேங்க்யூ ஜென்னி. ஓகே, மீட்டிங்ல இருந்து டிஸ்கனெக்ட் பண்றதுனா பண்ணிக்கலாம் கண்ணா. தேங்க்யூ ஸோ மச். நம்ம வந்து நெக்ஸ்ட் கிளாஸ்ல மறுபடியும் பார்க்கலாம். Bye guys, bye bye, good night.
Thank you, ma'am.
Bye, bye Mushkan.